Okay, so this is my first sort of demo of a system that I've written called Improve for doing sophisticated C++ refactoring. I'm using it to improve my own code. I've got about 250,000 lines of code, which is my a C Common Lisp compiler and system written in C++. And what I want to do now is I want to switch it from using intrusive reference counting for its garbage collection, which is amateur hour, to using a copying professional garbage collector. And so what I need to do is I need to track down every pointer use in my program and create sort of garbage collecting code for it so that every pointer gets garbage collected. So what we have here is an Emacs window. Here in the bottom left is the beginnings of the refactoring program. It's written in Common Lisp, or my sort of superset of Common Lisp that my Common Lisp system Clasp runs. And here in this window, I'm going to just start up an inferior Lisp system. All right, so this is loading my Lisp. It's loading in all the Common Lisp, compiled Common Lisp code that builds a system. It's a little slow right now, I think largely because it's using this intrusive reference counting, which requires a lot of housekeeping to create and initialize and destruct objects, pointers. Right here we're in the REPL, and we can do things like print hello world, and it'll compile it into native code using the LLVM just-in-time compiler backend and run it. Okay, and what I can do here with this inferior Lisp is I can move the cursor onto a S expression in this demo window here. And the one that I moved it on, what that's going to do is it's going to load the code for Improve, for the Clang, the stuff that talks to the Clang refactoring libraries. It's written in Common Lisp. So we load that up. And again, it's a little slow. The whole point of this is to speed this stuff all up. Okay, so it's loaded that module. So now I come down here, and this progin will do a couple of things. It is going to load the compilation database that describes my entire compile build system. There's about 165 C++ files in this build, and what it's going to do is load instructions in so that the Clang refactoring backend knows how to compile every source file in my system. Okay, then what it's going to do is this lclear, what it's going to do is create this global variable called $test, and it's going to clear it, and then it's going to initialize it with one file name called one source file called test ast.cc. This is a regular expression that will match that, and what this is going to do is pull out of all the files in my the build system just this one file. This file is just a little test file that I've got right up here, which just defines a couple of structures. Okay, so the first thing it does is includes a bunch of header files. So this is header files for the C++ code for my Common Lisp system. And so it defines some structures and a couple of goofy little functions. So this doesn't really do anything. It's just to help me build this refactoring tool. So I can put some example code in here and then have the refactoring tool look for it. Okay, so we put the cursor on this progin and we send it to the REPL. And over here on the right-hand side, it gets the compilation command for that file. It runs it through the front end of the Clang compiler. It takes about 5 seconds. And now what it's done is it's built an abstract syntax tree, a sort of mathematical representation of this code and all the header stuff that was included. It's built that, and it's now in the Common Lisp system. Okay, so let's go down to the refactoring tool. Okay, so here is how we start building. Let's get this all in the window. Okay, here's how we start building this refactoring tool. Okay, so this progin is doing two things. One, it's defining a parameter, a global, sort of dynamic global variable called ASTMatcher, and it's got right now just one single sort of test thing called a record decal. And then here it's got a thing called match count, which is a function which will take this sort of description of what we're looking for in the C++ code, and it's going to search the abstract syntax tree that's loaded in here for the pattern that I'm going to describe here, and then it's going to do stuff with it. So right now, match count, all it does is it looks for how many instances of record decal nodes there are in the AST and counts them. Okay, so record decal is any C++ class definition or struct. Okay, those two things are record decals, and that includes template classes, template structs, all that is going to be included in. So if I go on here and I just send this to the REPL, what it's going to do is, it takes less than 1.5 seconds, and what it's done now is it's searched through the abstract syntax tree of all this header code and this stuff here, and counted how many times there are C++ classes or C++ structs defined, and there's 34,061. Okay, and there's that many because we're including these header files. These header files include other header files. Those include other header files, and there is just loads and loads of stuff that gets included into every C++ file. And so there's 34,000 classes that are defined, even just this little tiny program. Okay, so let's just take a look at this a little bit. So what I'm going to do is I'm going to say, let's run a little bit of code on every one of these matches, but we're not going to do all of them. We're just going to limit it to the first 10 matches. Right, so match run, what it does is it will run this matcher, looking for classes and structures, run it on the abstract syntax tree again. It's going to just pick the first 10, and it is going to execute this code on it, which is just going to print a bunch of stuff. It's going to print match. It's going to tell me the source file, the location where that class or struct was defined. It's going to give me the name of that class or struct, and it's going to give me the namespace of that class or struct. Oh, but hold on. Because this matcher doesn't have anything in it, I've got to take the namespace out because I don't actually do anything with, I don't actually define any namespace. So let's run this again. Okay, so we get this stuff here. We see that there's a match in user include I386 types.h line 76. Okay, so we could go there. So xf, let's go there and see /user/include /i386/_types.h, and then go to line 76, and there is a, oh, I guess we pick up unions as well. I guess those are record decals as well. So this is a union. Let's see, the other ones are all p threads here. Okay, what I'm going to do is, because we've got so many, we've got 34,000 hits here. Let's pare this down a little bit. So let's go back to our test AST. Let's go in here. Now, I've already created a matcher that does sort of what I'm looking for, which is look for classes and structures in my own code that may contain pointers that I'll have to garbage collect. So what I want to do is I just want to find stuff in my own code and not the included C++ header code. And so what I'm going to do is start beefing this matcher up so that it'll look for stuff like that. Now the first thing I'm going to do is, let me show you what I can do. Okay, so one thing is about all my classes, they're in a collection of namespaces that I defined in my code. So what I'm going to do is I'm going to limit the search to just classes that include my my own code. So let's grab this from another file here and put this in. Okay, so here we've got a little bit more. Okay, so check all our parentheses are matching. Okay, so here's what we've got. Okay, so record decal matches classes and structs, like I said. This has ancestor test. What that does is it says, does the class or struct have an ancestor? The code that contains that class or structure definition is the ancestors. And so what this does is it looks for ancestors, and it looks for ancestors that are declarations of namespaces. And then here it says, okay, if I get a namespace, if it's any one of these namespaces, if it has the name translate, GC tools, mem, core, CL, CL user, extension, keyword, these are all namespace names that my code is wrapped inside of. Now, I really should have put everything into one big namespace. Like, it's okay to have all these individual namespaces to break up the code, but I'd really like to wrap all of these namespaces in one that's like a Clasp namespace. That would have made this much simpler. I'm going to do that later on. I don't quite have that here. Excuse me. Okay, so so this will just look for classes and structs in the namespace. Now, this thing here, this command here, what this does is it says, once we find whatever namespace we find, if it does match these things, what it's going to do is it's going to take that namespace, that node that in the AST that describes a namespace, and it's going to bind it to the name :ns. Okay, so this is the keyword symbol that it's going to bind this namespace to. So then I'm going to be able to, in the code down here, pull out that namespace node and interrogate it and get information about that part of the C++ code. Okay, so let's bring that back in. So now that we are defining a namespace node, we're going to be able to access it here with this format. So format is like printf in Common Lisp. Format is equivalent of C. It's printf statement. The T just says send it to the terminal. This says print namespace, and then here we have twiddle A. That means take whatever comes in here and substitute it in there. It's kind of like very much like printf. So this mtag name is a function that I wrote. It takes the namespace name :ns and it looks up the node for that name that was bound here and prints the name of the namespace node. So it should print one of these names here. Okay, so let's send this. All right, so here we go. Now we have, okay, we've got 10 matches. Let's just see how many this reduces it to. So instead of running the code, we're just going to count. So match count will count the number of nodes, but it's not going to run the code on them. It's just going to ignore that command there. So we do this, and now we have only 1,142 classes and structures that are defined within my code. So let's just print 10 of them. Okay, so we'll run this code on just the first 10. Okay, so what do we got here? So T_O, that is a class that I define in my code. All my Common Lisp classes are suffixed with _o. So we got T_O, symbol _o, pointer, stack bound class, that's one of mine, GC ignore class, that's one of mine. This is all my stuff. And the namespaces are core, GC tools, reg. See, these are all my namespaces. So we've weeded out all the C++ header stuff that isn't, that I didn't myself write, and all we're getting now is just classes and structure definitions that are within my code. Okay, let's so let me just say a little bit about this thing here. Okay, what this is called the AST matching language that was developed by the by the people who are developing Clang, by people at Google and by people at Apple, and it's really powerful. They've got a form of this. If you just Google ASTMatcher reference on the internet, actually let me just do that. ASTMatcher reference. Okay, the top hit is going to come up, and what we're going to get is this page here, which shows, so what this is the way they sort of define the language. It's just a whole bunch of, it's a sort of a functional language where you just string all these function invocations together, and they've got all these different functions that you can use that recognize different parts of the C++, C, and Objective-C abstract syntax tree. So there's a lot of these things, and it takes some time to kind of figure out how to use them all. There's basically 3 classes. There are the node matchers up here. Okay, node matchers, they match things like, class definitions or structure definitions or if statements or while statements and for statements and also, namespace declarations in C++. Then you've got narrowing matchers. What they'll do is if you've got a node, they will apply tests to it and either come up true or false if that test is true for that node. So you can weed out nodes that you're not interested in. And then there are traversal matchers. And what these let you do is they let you go from one node to a node that's sort of associated with the first node according to some property. Like, if you're on a, you could look up, for instance, a variable declaration, where you declare a variable in C++, and then by using a has type matcher, you can get to the type of that variable declaration. Okay, so that's how you use all these things. Now what I've done is I've taken every one of these and I've made a Common Lisp version of it. So instead of you saying has qualifier, in camel case, the way it's described here, in my approach, you use :has dash qualifier. Wherever there's a change in case, in the camel case C++ name, all you do is you stick in a dash. And you prefix everything with a colon. That's so we don't have to worry about namespaces and packages in the Common Lisp version. And then the other thing is, rather than using, the way you declare, you use functions in C++, you have the function name, open parenthesis, arguments separated by comma, close parenthesis. This is doing it the Common Lisp way. These things are called S expressions, where you have an open parenthesis, then the function name, and then arguments separated by white space, and then a closed parenthesis. So it's very, very similar to this. Okay? This language and this language there's a one-to-one map between them, so it's very straightforward. All you have to do here is put colons in front of the names, change in case to dashes, and move these parentheses from here out to here, and this one to here. Just move the parentheses out one level, and you've got this translated directly into this. Okay, so there's a one-to-one match, and I'm one-to-one mapping both ways. And what I still need to do is write something that will take these and then turn them back into the C++ form for people who want to write C++ refactoring tools. Okay, but the nice thing about this is that it's really easy for the Emacs to identify what the full expression is and just send the thing over to the Common Lisp running here in this REPL. Okay, so we've narrowed this down. Let's fix this up a little bit more. Okay, so another thing that I can do is you can string together more and more of these predicates, more and more of these tests to make more and more complicated, sophisticated tests that will search out different patterns in your C++ code. So one thing is, in this thing right now, we'll find record declarations, classes and structure and union declarations in C++ code that are within these namespaces, but it's going to give me both forward declarations for classes, and it's going to give me the declarations that have definitions associated with them. And I just want the ones with definitions, the ones that have bodies associated with them. I don't want the forward definitions. So what I'm going to do is I'm going to add another predicate. And actually, let me show you something here, okay? Writing these things is a little bit painful, because when you start out, you don't really understand the structure of the C++ abstract syntax tree. You don't really know what predicates, what tests you can put in here, and it can be kind of painful. And there's rules to it. And so I've taken those rules and I've figured out a way to sort of build a hint system, a system that gives you hints as to what you could put in. So if I put in a predicate like this, which is just colon question mark, this is asking for a hint for what can I put into this position of this little program I'm building up that would be useful to move me forward. So I'm going to put that in there and do this. And then let's go here, scroll down to the bottom. Okay, so this gives me the hints of what I can do. There's certain like node matchers I could throw in here, and these are listing all of the node matchers that I could throw into that position. Here are all the narrowing matchers. For instance, I could ask, is this a private class? Is it a protected class? Is it a public class? And it would then only give me private, protected, or public classes. I want things that are just definitions, so I'm going to use a narrowing matcher that says, is definition. So that's what I'm going to do here. I'm going to put is definition like this, and I'm going to run this now. Okay, so now I've got limiting. Let's count and comment that out. Okay, so now we have just 370 matches. You remember previously we had something like 1,100. Okay, so that weeds out a lot of forward declarations of classes and structures and unions. I don't really use unions, but classes and structures. Okay, now, another thing that I've done is, in this garbage collector, there's certain classes that the garbage collector is just not going to be interested in. You know, classes that don't contain pointers, classes that I only ever declare on the stack. The stack searching part of the garbage collector will take care of those. So I want to limit my search even more by just picking out potential classes that will be that I need to take care of, I need to handle in the garbage collector. So I'm going to copy in another chunk of code here, another window that's open, and this one is going to make sure I match all my parentheses here. Okay, I am. Okay, so this one here is pretty interesting. It's got this unless. So this is a test that will it'll match a node unless one of these things is true. So what this says is it says unless any of these situations are true, will the node match. So this is testing, is the class derived from another record decal that has the name stack-bound class. So if it's a class that I'm only ever going to use on the stack, I'm never going to declare or create any of these classes on the heap, then I will make them inherit from stack-bound class, and this test here will throw them out of it'll cause them not to be recognized by this whole matcher. Okay, and then the other thing is this one here. If they're derived from a class called GC object. GC objects are all these objects that ended with underscore, let's see in here, but underscore O. I handle those differently in the garbage collector. I've already got a big chunk of code that's a static analyzer that takes care of those. So I'm not going to worry about these here. I'm going to handle them in a different chunk of code. Then this next test, GC ignore class. This is a class that I've designated as just not interesting to the garbage collector. They're actually just well, they're not things that I ever declare anywhere. I just inherit from certain kinds of classes. In some cases, it has to do with the template programming. And so I just make them inherit from GC ignore class, and this is a signal to this pattern matcher to ignore those. Okay, and then I store all of my pointers in these two template classes called smart pointer and weak smart pointer. I don't want to recognize those guys because they are They're classes, they're template classes, but they're sort of the atoms that I'm looking for inside of other classes, and I don't really want to recognize them by themselves. So I've ruled out anything that inherits from any of these classes. I'm not going to I want this pattern matcher here, this ASTMatcher, not to recognize those. So let's send this to the inferior list window, and now we've got 153 matches. Okay, so let's look at some of these. Let's see what we were getting here. Okay, so now I'm still working on this thing, and I'm going to narrow it down a lot more because, well, 153 still seems like a lot, but I can't really be sure. It could have the, it could be pretty close here because there's a lot of stuff included in the headers. So let's send this. So we'll run the matcher on the first 10. So we got one called heap root, stack root. Okay, these are going to have to be excluded because they're part of the garbage collector and machinery. Multiple values. Okay, that's an interesting one. That's a class that stores multiple values that are returned by the Common Lisp, and it's got some pointers in it that I'm going to want to have to garbage collect. A string stack. Some of these things won't contain pointers that that the GC will be interested in, and I'm going to have to weed those out still. I don't know what this is. No name. Down here, it's F, course, foundation, H, and then we'll go to 701. Oh, interesting. This is an old style. It doesn't have the name up here. It has it down here, so that doesn't give the name the same way. It doesn't contain any pointers, so I'm probably not going to care about it, but I will have to deal with this. Okay, functoids. These are my sort of functors. Some of them contain pointers I care about, and I'll have to worry about them. Invocation history frame. Whenever one function calls another function, it creates a frame that keeps track of, sort of debugging symbols, and it's for the stack callback trace. So yeah, this stuff I'm going to have to worry about. Okay, so it's pulling up classes that I care about that the garbage collector is going to have to deal with to find stuff that matches. Okay, so I'm on my way here. Let me show you a couple of other things that I have done here that I think is pretty cool. So another sort of example is, or another thing I can do is, so I've got this this test.ast.cc file, and in here I've got some structures that have things that are definitely going to have to be garbage collected. Like I've got a symbol pointer, I've got a map of integers to symbols. And this map, all this stuff is going to be on the heap, and the garbage collector is going to have to look through them to designate them as roots. Symbol map, it's going to have to look through that. A vector, this is a bit of a mess. There's a lot of stuff in here. Then I've got this structure here called ignore struct. This is one that so let me put it this way. I want this pattern recognizer to recognize this structure declaration. This one here, ignore struct, inherits from GC ignore class. I do not want it to recognize this one. Okay, and I think the way it's set up right now, because this says ignore GC ignore, anything that inherits from GC ignore class, and this inherits from GC ignore class, it should ignore this. Okay, now here's how I'm going to test this. I've put these comments above them, okay, // bang, and then my test 1, and // bang, my test 2. These comments are handled by Clang, the front end, and they're associated with the nodes of these structure declarations. This is really cool, because here's what it lets me do. Okay, in this matcher, this match finder here, I can put this keyword argument here, match comments, and then I can put a list of regular expressions that have to match these comments. Okay, so this is saying, well, okay, this is a little difficult to describe, but if I go here and I say, instead of match run, I say match comments. What I'm asking it to do is to look for matches in the code, and if those matches have comments associated with them, like these, that match these regular expressions, then run the code on them. Okay, what this lets me do is write little examples here that may or may I want or I don't want to be matched by this thing. And this will just focus in on those and tell me whether it matches or doesn't match those ones. Okay, so writing these matchers can be kind of like stumbling around in the dark, you know, with basically it's like you're stumbling around in the dark in an airplane hangar, and there's airplane like a 747 in there, and you've been given instructions to find one part and to bring it out of the hangar, except it's pitch black and you can only feel them, and you've got instructions that are written in Greek. And putting together those instructions is what we're doing here to give the guy to go in and find the part. And it's a little bit of an exaggeration, but it's about that difficult to write these little programs when you first start out. So I'm getting a little better at it, but it still takes some work. And the hint system really helps out here. Okay, and these comment matchers, I think, is really a powerful tool as well, because I can just write some example code here and then have it run. So let's do it. Okay, so match comments. Here's the comment. I want to see, does it match anything that's got a comment that has my test in it, my test 1, my test 2. So let's run this, and okay, so we get, in total, there's the recognizer, the pattern matcher here will match 153 nodes in the AST. Of those 153, it found one comment match from my test 1, and that is the tiny struct in the AST tooling namespace, AST tooling, tiny struct right there. So this matcher matched this one, but it did not match this one. Okay, let me change something here. So I'm going to just put some garbage in here, in here. So now I've broken the test for GC ignore class. If you have a class that inherits from this, send that over. Okay, and now it finds both of them. I find this really awesome. Okay, so now I know that my matcher here is broken because I want it to match this, but not this. So let's just take this back out. And there we go. Okay, so this is the first video that I've ever made of this kind of stuff. I hope you enjoyed it. I'll put up some more, but just sort of demonstrating a few of the capabilities of writing ASTMatchers and refactoring tools in Common Lisp, and doing this sort of interactive refactoring tool generation writing. And I'm using it to implement garbage collection in my Common Lisp that's running this whole thing. It's so meta, I love it. All right.